Examples now that pushes things a little bit of a notch up, where we actually are considering grade 12 work as well. And the one that we are looking at over here is actually going to be 4 sine x cos x, right, is equal to the square root of 3. Now, what does this involve? Well, this looks a little bit more of a challenge, and we're going to try and make this look familiar. And how we do that is by actually using the double angle identities. Now, if you go back to your summary sheet, you can see here, when I have sine A multiplied by cos A, that sort of looks like a double angle identity for sine. Now, there's a way we could do this. We could say 4 over here is equal to 2 multiplied by 2 sine x cos x, right? We see that is equal to square root of 3. Is equal to the square root of 3. Now, let's isolate this. Let's block off that. And now you still have this 2. Let's divide both sides by 2. And then that's going to give me 2 sine x cos x is equal to the square root of 3 divided by 2. Now, root 3 over 2, that's nice. Now, people, let's use sky blue over here. 2 sine x cos x. You happen to know that that is an identity for sine of 2x. 2 sine x cos x is an identity for sine of 2x, right? So if I put that in over here, I'm going to get that that thing is equivalent to sine of 2x. And that is equal to root 3 over 2. Now this is very easy because now I've got an angle, I've got a number, and I've got a single trigonometric ratio. Now we can use our Qrs approach. So for the quadrants, since this is positive, I'm working in the first quadrant, and I'm also working in the second quadrant, right? So what does this look like? Well, that's the quadrant. Now I solve for 2x, which is solving for the reference angle. It's going to equal to sine second function of root 3 over 2. And we know sine of 60 degrees is actually root 3 over 2. So therefore 2x must equal to 60 degrees, right? And so that is my reference angle. So our reference angle is 60 degrees. Now let's go ahead and solve this. In the first quadrant, it's very simple. In the first quadrant, it looks like this. I've got 2x, which is the given angle, is equal to this angle here, which is just simply theta, 60 degrees, plus n multiplied by 360, such that n is an element of z. Now I divide both sides by 2, and I get x equals 30 degrees plus n times 180 degrees. N is an element of z. Okay, let's go to the second quadrant now, which I'm going to do on this side. 2x is equal to 180 degrees minus the reference angle, which is 60 degrees, plus n times 360, such that n is an element of the integers. Okay. Therefore, this tells me, again, 2x is equal to 120 degrees plus n times 360, such that n is an element of the integers. And now I can divide everything by 2, and I get x is equal to actually 60 degrees plus n times 180 degrees, such that n is an element of z. That's the restriction. Okay, so there's an example of grade 12 question that involves both a double angle identity.